Let's practice some chain rule. There's all kinds of examples we can do. Anytime one function is inside of another, we can use the chain rule. So the first thing I want you to do is for these three examples on the board, find the inside and outside functions. The outer function will be y equals something. Even if there's another function notation, I'm just saying y. It makes it easier in my brain. And then u is our typical substitution for the inner parts. So go ahead, pause this video, and just see if you can figure out what are the outside and inner parts of these. So this is a good way of breaking it up. How many of you thought to go ahead and just make that u to the negative fourth power? It's this group of stuff, and it's in the denominator, so we make it the negative fourth. That's a little tip, a little trick for you to learn here. As for the rest of it, it's pretty casual, except for this inner function. Notice how I wrote. This is just a coefficient. I don't want to do any quotient rules here, so I left that as a coefficient, a number times x. Down here, I did leave it as a quotient. If you really wanted to, you could rewrite that this way. I don't know if it makes much of a difference. It might make a little bit. Your choice. I don't care which way you do it. Now take the derivatives of each of these parts. No, you do it. Pause the video and take the derivative of each. Stop waiting on me. It's on you. This is your learning. You do the derivatives. All right, already. I did them. So here's your derivatives. And remember to get these, dy over du times du over dx is going to give us the derivative that we're looking for. So combine these as best you can. And then, of course, once you combine them, tell me what u is equal to. Back substitute to get that answer. Oh, and this is so special. Of course, you got the first example and the second example. But the third one, did you ever think of this? If this is to the negative 2/3 power, a negative exponent means take the reciprocal. The reciprocal of u, you can just flip them. You can write it as the reciprocal, and now it's to the positive 2/3. That's a great way to finish that one. But these are still just basic examples, just basic. We could do so much more. Let's try another one. How about a triple product rule? What do I mean by the triple chain rule? Let me tell you. Let's go. You start with the outside function. That's the biggest, overwhelming, overarching function. We're taking something to the fourth power. Then you say to yourself, hey self, what are we taking to the fourth power? Well, cosine. But cosine of what? Maybe we need something else. Oh my gosh, a third one. Who'd have thought? Now we have, well, honestly, in a chain rule, you can have as many inset functions as you like. Think of it as that movie, what is it, where there's one life inside of another life, inside another life, Leonardo DiCaprio. I'll think of it later. Anyhow, we're going to do this the same way. Take the derivatives of each individually. Once you have them done individually, we're still going to multiply them together. And I really don't know where the word for the chain rule came from. I've never looked it up just because I'm not all that serious. But in my brain, I start looking at how, that shows up better, how all of these different functions can go together, and it sort of looks like a chain link fence. So you're going to multiply them together just like you did before to find dy over dt, the derivative we were looking for from the beginning. And honestly, the hardest part here is probably back substituting. You have to make sure you don't get confused what u and v represent. So it might take you a couple steps like this. Substituted for u, substituted for v. I still have to substitute for v again. It might take you a couple steps like this. And by the way, it's easy to take all your numbers, maybe your variables, pull them out front. There's a negative and a negative, 32 times 4. Get all those nice little coefficients out front. And I'll show you a quad in class.